Hello everyone, hope you can hear me. Give me some thumbs up if you can hear me. Hear me. Okay, thank you Himapriya. I will start my screen share. We can get started. I can hear some echoing, but I'll adjust with it. I hope you don't hear it, the echo. Okay, let's do the screen share. Mm, the in-print screen share. Huh? Okay. So, welcome everyone. Today is the first meeting for tech enthusiasts, and I am the presenter here. I'll walk you through some of our basic principles and disclaimer before getting introduced and started. These are some of our principles at Tech Enthusiast. The first quote from Dalai Lama 14: share your knowledge. It is a way to achieve immortality. Learning is not attained by chance. It must be sought for with ardor and attended to with diligence. Well, every girl. These are core principles for which we stand for and why we started Tech Enthusiast. And um, this here is some disclaimer for everyone listening. The views expressed are solely those of the speaker and do not reflect the views of their employee or affiliated organizations. The information presented is for educational purposes only and should not be taken as professional advice. No endorsements of any products, services, or organization is intended by the mention. Content is accurate to the best of the speaker's knowledge as of the presentation date. Future changes are not accounted for. Content is recorded. Deck for sharing after consent from me is available. The code that we'll be walking through the presentation is also available on GitHub for free. And I also have a blog written for this presentation that I'll share towards the end of this presentation. The topic today is AutoGluon. It is a machine learning library which you can use to get started with training your prediction models right today. And it simplifies things a lot. Now, before getting started about AutoGluon and the presentation, a little about me, the speaker. I'm Paul Anthony. I'm a cybersecurity engineer. I work at Amazon today. I have about 12 plus years of experience in the tech field. My hobbies, I love to play badminton, go on long drives, walk along with my wife. Um, a new interest of mine is FPV, which is first person view. You could fly drones with first person view. That's something that I just started. Um, And over here, I also have my LinkedIn profile. So feel free to connect with me over LinkedIn and send. And I'm always up for discussing tech and cybersecurity. Now, who is this presentation for? Today's tech enthusiast video that we are looking at is meant for people ideally in the tech field, even if you're not there, but if you have a little experience in Python and minimum to no experience in machine learning, you will, it would be suitable for you. Now, that said, I will try to give us as much explanation as possible within the presentation time. We will also have a Q&A session towards the end when you can feel free to ask any questions related to the presentation, and I'll stay back and answer any of your questions over. Now, getting started, for today's agenda, we are going to look at, we'll start with a high-level overview of machine learning and artificial intelligence. And then when we should think of using machine learning projects for your projects, machine learning for your projects. What are modalities and its types, some general steps involved in machine learning, how AutoGluon can simplify things, a quick demo where I'll walk you through the code live. We will provide the code in GitHub, as mentioned earlier. So along with how to set up the environment, there is README instructions in there that you can follow up. So you could test it out at leisure later on. You don't need to follow me and code it out during the demo. And like any other interesting presentation, bonus slide with suggestions on how you could continue your learning is that towards the end of the presentation. And finally, the Q&A session. Now, talking about artificial intelligence and machine learning, what are they? They are often clubbed together when we refer to them as technologies. They are different, and wanted to dive a little bit, give a little bit overview here. Artificial intelligence is the ability of machines to imitate us human beings, humans' intelligence, while machine learning is a set of algorithms to incorporate intelligence into machine by automatically learning from data. Machine learning is a subset of artificial intelligence, and it's not everything. So there's a lot more to AI than just ML. Now, a lot of us would have also heard about LLM or large language models. It has captured many of our hearts and wows. They are AI models trained with these machine learning. They are AI models trained with these machine learning algorithms using data. Now, today we will be learning about how we can use ML to do predictions. Once you are familiar with concepts here, you can understand some of the inner workings of LLMs, like large language models, and draw parallels to it. Even within ML, there are various types that we should probably touch base on before we get started. And that is, at a high level, there is supervised learning and unsupervised learning. Examples of supervised machine learning are regression type problems, which is based on numbers, so predicting numbers for us, or classification based supervised learning, which helps in classifying based on given data. There is also this unsupervised learning, and examples of it is clustering. And the term means what they say, right? Supervised means some supervision is required. Unsupervised is you could it's unsupervised, the training process. It is. an example of unsupervised training and execution process. The unsupervised part, some example is clusters and clustering. Large language models, for instance, they use clustering to understand similarities between words in English, for instance. And that's how they are able to see, okay, if we write something like football and basketball, it knows that, okay, they are ball, it's a ball, and it could cluster it together and say, okay, this is something similar. And that's how it is able to communicate with us eventually. But that's just one part to LLMs. There's a lot more to them, which we don't have time for this presentation. Maybe in a future one, can dive deeper into it. Now, going back and drawing parallels, I would say that LLMs are part of artificial intelligence, and that development often involves these ML algorithms, some of which we'll be discussing today. Note, I've mentioned two here, but some, just two, supervised and unsupervised, but some sources I've seen have additional types of ML mentioned as well, like semi-supervised, reinforcement, and others. Now, that said, once you think you want to use ML for your project, what are the steps involved? When you think you want to use ML, that is. The first step is, do you really want to use ML for your projects? You should ensure that. And machine learning is interesting, but and all of us want to jump into it, but it's not a straightforward and as simple as a codable logic. It can pretty quickly also get costly in terms of resources. We might need GPUs or storage spaces like data, and also consume a lot of time. Hence, we should make sure that ML is needed before we dive into it. Some guidance to determine if it is needed is the project too complex to code the logic? If it's codable, do code it. That's easier. Is scalability going to be a challenge? Like, how are we going to interact, and how is the responsiveness and automation needed in that case? Thinking about all of those aspects. And the last one is, does it depend on data and can change based on certain data? Remember, machine learning, we use data to train the models, right? So if data changes, then a machine learning model can adapt to that changing data. Now, if a majority of these conditions that we just discussed are satisfied, then using ML for your project should be considered. Once you have decided you need ML for your project, there are some major steps you should expect. And those steps are, the first one, we, as I said before, we use data to train our machine learning models. And hence, we need to prepare this data, understand it, and decide on what parameters or what columns or fields could determine the value we want to predict. I'll dive a little bit deeper into it in the demo while we look at some example data. Once we decide on the data set, the next steps is separate. Is to separate the data out into training data, using which we will train our machine learning model, and the test data out of the main data set to validate and check how well a model is performing. A quick tip on this, ensure we are not using the values of the test data to train the model. Using the test data to train it will make the validation incorrect, because the model will already know the values for the test data. Right? So that's a newbie mistake that I did when I first started out training models. So yeah, and The other point after that, you would test your data and how valuable those individual parameters you've selected are to predict the test data. We could do some data engineering where we manipulate the data set, massage it a little bit, and or derive data out of one column and put it into separate fields, play around with the data set a little bit, which might increase the accuracy of your model. Now, and go through the process again, the data engineering and all of what we discussed. So getting more data to train or providing more time for training helps in increasing accuracy up to a certain point though. That said, when we talk about data to train, we come across certain machine learning terms like modalities. And what is this modality? Modalities in this context refer to different types or categories of machine learning problems. Some of the types are text-based classification, images-based classification, time series-based predictions, like how much a product is going to sell in a shop, for instance, or tabular-based predictions. Tabular-based prediction is something that we are going to look at in today's demo. Um, and so far, notice that we have discussed about various steps needed and types of ML. Even though I listed it out quickly within a few minutes, implementing various ML models could quickly get complicated due to how we use data to train these models. But as discussed, primarily they follow those steps that we discussed earlier in the previous slide. So to simplify our lives and bring all of the training of different ML models that have come by throughout these years into a single library, we have this library called AutoGluon that we are going to demo and test and work with today. AutoGluon really simplifies machine learning for us. It allows us to use various different types of modalities, including image classification, text classification, time series prediction, or tabular predictions. So different modalities right there. It has different models that it would train altogether. So you don't need to know how each model would work individually. It, as long as you just give it the data, and all of them are just 3 lines of code usually, and you should be able to train your models. You just need appropriate data, and you should be able to train models and do predictions with them. They do have a lot of different parameters that we could tweak to increase accuracy and play around with things. So it's really interesting. And next up, we have a demo, so we'll get right into it. For the demo, we will be going through AutoGluon, some basic setup, execute it on a small data model with less number of data, and then execute it for a bigger, larger model with more data set and show the difference. Now let's get into it. Hope you can still see my screen here. Please do let me know if there are problems, and I would make sure that it's visible. For the demo, this here is a Jupyter Lab notebook. This can be easily downloaded and set up in your system. I've provided detailed steps on how you could set up Jupyter Lab in my GitHub repo, where I have all of this code as well for you. I have the GitHub report towards the end of my slides, and it will be shared in the comment section for this video, so you should be able to pick it up from there. For the demo, first let's start with setting up Python virtual environment and enable it. There is, I like to keep my libraries clean. If we already have some libraries installed in our system, sometimes there might be dependency issues, and so creating a virtual environment really is helpful. And so running that, and once this is done, so the kernel is running and preparing my virtual environment, and it's done now. Next, we can just activate this virtual environment. And next up, after that, we'll install pandas library into that virtual environment that we just got up. And so this circle here, I'll say, okay, overwrite. It implies when it's solid, it implies that it's working, and when it's just a circle with the boundary, it means it's idle and ready for next execution. So pandas is installed, and next is installing AutoGluon. AutoGluon is a little bigger library since it has a lot of machine learning components to it, and usually takes a few more minutes, a few more seconds compared to pandas. That's done. Then we need to import some libraries. We are going to do tabular-based prediction today. So we are going to import from the AutoGluon's tabular library, we are going to import two packages, tabular predictor, which would be used for predicting values, and tabular data set, which would be the data structure we'll be using, which is in AutoGluon's tabular dataset format. We'll also have pandas to play around with the data a little bit, handle our output, and show some results as we move. So importing them. And then over here, if you see, there is two variables we are going to take up, the train data variable and the test data variable. The train data variable is within train underscore car.csv. I have that file right here. I got the whole data set from Kaggle and divided that into train data set and test car data set before this session. So we'll import both of them. And as you can see, the first train data has around 21,000 lines entries, and the test data has around 1,000 lines. That's how I've divided it here. I had 22,000 lines in total and just separated them out. Next, let's look at a sample of data from train data to get an idea of what it is. And that way I can also explain the data engineering part to it. So we have name, year, miles, and price. Price is going to be what we are going to predict. Name is the car company's name, the model name. Year is the year of that model. Miles is the number of miles the car has been driven. And price is the current price of that particular car. So this is the training data. And if we look at our test data, it wouldn't have the price column. I just removed that part out. Now, that said, to make things simple and quick, I'm just going to do a sample size of 1,000 so that the models get trained really quickly, and we can also see see how the number of values we are using to train our model really affects our predictions. In this case, we are taking 1,000 as a sample size, and random state is 0. So we can use the sample function within tabular data set. So that is train.data sample and the sample size of 1000. So this will get 1000 lines out of train data for us. And it's called train data sample. And this is some of the examples that we have within train data. Next, now that we have our training data, we will get into our model preparation. So we have the tabular predictor function, and we have a label mention. Label is the value that we want to predict. It's there in the train data small, but it's not there in the test data. So that would help us predict it. Then eval metric is just a way for us to evaluate our metrics and the performance of a model. We are using mean squared error here. And path, it is a folder we are providing so that AutoGluon can store a model within that folder. Then we are going to fit the training data small to train this model called predict smaller. So I'll run this, and AutoGluon should automatically start running things. There is also some other parameters that we could potentially use. We just had train data small in this case. Let's say we could add another key value called presets and provide the value best quality for high accuracy, and high quality preset equal to high quality would have a little lesser accuracy, and so on. There is also this field called time limit that we could set within the fit function here, fit method here, and so that also works out well. I haven't put the default time. I haven't put a default time limit here. So it, because this is just a small set of data, I'm not going to bother much on that. And as you can see, it's running. It's going to use different models. It's going to train different models for us. All by itself, we just had to give those minimum number of parameters, and it takes care of it. These are different ML models that we are looking at: NN Torch, underscore Torch, GBM, CAT, XGB, Fast AI, RF, and so on. So it's also saying how many rows are there. There are 800 rows that it's using for training here. And 200 for validation internally. So that goes on, and now that our model is done, we can click on leaderboard to see how well the models have performed, to get an idea. So these are, we have 9 different models that AutoGluon has trained for us. These are all machine learning models. The score value tells how accurate the values are. The predict time val tells how much time it's going to take to predict values for us. And the fit time is how much time it took to train the model. We haven't done any predictions so far. It's just creating the model. We have it under the predict smaller folder here. That's where we gave it within the path parameters to store the model. Now, before looking into the predict results, let's doing the prediction. Let's look at the test data. As I told you earlier, there is no price column here, and we need to predict that price column. So that's there, and over here, with the learn step, we are going to use price predict equal to predict smaller dot predict. This predict function is going to use the predict smaller ML model that we just trained a few seconds before, and it will provide it the test data, that is this data. And so this means that it's asking the predict smaller model to predict the price value for the test data and provide that as input into price predict. And so in this print statement here, we are going to print the first 10 values that it has predicted. It just took a few seconds there, barely 1 second, yeah. And you see it has gotten some results that we have. Right now it just shows the price for each of these. It's arranged in the same order. So it's saying that Toyota Camry 2019, this much miles, would cost 24,000. And just to compare this with the actual values, I have that set up later, but we are first going to add some additional fields to it, like context, like the name part at least. And to do that, I played with a little pandas here, added 2 columns to a data frame, name and the price field. And to that output pandas data frames, we are adding the fields within the name here by doing this step. And so we'll just have the names within our first data frame here. So you see, this is this data frame with just the names in. We don't have the prices yet. And this step here is going to add the values that we got from price predict, the predict function that we used earlier. So now this is going to show the name of the vehicles and the price. I went added the year and miles just to keep it simple. And this test actual is the original file from which I removed the price values so that we could compare and see how well this model is doing. Over here, as you can see, this is 24,084 for Toyota Camry, and this here is 24,590 for the same Toyota Camry. The other one is 24,642, while this is 24,990. Closer, but still you can see that there is a lot of difference in the values in here. So we could just save the results in output smaller.csv. That's there here, it got saved. And once that's done, this here is going to be the larger model. It's going to take some time. The time set for it is about 5 minutes. It's just 10 seconds right now, 10, 11 seconds, as you can see here. So it completes in about 300 seconds. And this is going to be a much better model because over here we are using trained data and not the trained data smaller. Trained data smaller just had 1,000 lines for training. And trained data underscore data has 21,000 lines for training. And as discussed earlier, I've set a time limit, which is 5 minutes. We could remove the time limit, add other parameters. Even if I remove the time limit and set it to high quality or something, default is 3,600. So if you want more time, you could add that as well. AutoGluon has a really good extensive documentation site which delves into all of these different parameters that you could play around with. And in this particular predictor, while training this model, I've requested it to again predict values for price. So it's going to train the models to enable it to predict price value. And the evaluation metric is again going to be mean squared error. The path where a model would be stored is predictor this time instead of predict underscore small. And so it's going to go through that. And since it's going to take another almost 200 seconds, I'll probably explain rest of the steps so that once this is ready, we could just brush through the rest of the steps. Once the model here is ready, um, we would be able to do the predict on it. Use predict function on the predictor model that we are just training here. So that would, and for that we will give the test data again and see how well this new predictor model, for which we are giving more data as input, is able to perform. Um, I've trained models that have taken several hours as well to train. So, but the thing is, the more data you give and the more time you give, it's not necessary that the model's prediction accuracy always increase. And that's where playing with the data a little bit, arranging the data differently. For instance, the data set that you can see here under name, there is Toyota and Camry here. So it says the company name and the model name. We could have potentially separated this name field into two fields, one called the company name and another called the model name. And that could have potentially increased the accuracy of the model here instead of just increasing the time limit. So we should be able to understand what parameters are contributing to the prediction target value and adjust them and provide that as training material for our model so that we get better results. Uh, um, it's at 2:31 seconds, so probably around another 61 minute for the model to get over. And let's see what we have after that. Once we predict the value, we are going to do the same thing as the previous time, arrange all the names into this data frame output data, and have a price column, and add the final prediction that we do here into the price column of our output data frame, and print the output data. So this output data would have around 10 values with the predicted values. And we are also using the actual data here. We're going to load this test actual.csv, which has the actual price that wasn't removed. And so we are going to print that as well. And we'll see which, if how the what's the difference and how accurate the predictions are now that we are using 21,000 lines for prediction instead of just 1,000 lines, right? So that's what we're going to do. And so this is finally done, around 310 seconds. Running this got us some prediction values for each of these names here. And I also ran the actual file. Now you see that the price for test Toyota Camry is 24,590. It's 24,590. The Kia Niro, it's 24,990. The predicted value and the actual value is 24,990. The accuracy has increased a lot, and that's how it works. And so just running through this, we were able to predict and increase our model's accuracy by giving it more data and time. I'm going to save this to output.csv so that I have it handy. And we are also going to look at some additional interesting things like feature importance. Feature importance function on the models would give us an idea about how important each of the column fields were for the prediction. For instance, it says that name has 10 to the power minus 7 importance, while year has this much, meaning year has more value for the predicted value than compared to the name. And the name has more value compared to the number of miles. So that's some inference that we could derive, and based on that we could adjust and create a new data set for our training, which might increase the accuracy. Like we discussed earlier, we could separate this into maybe company name and model name, and then its importance would increase. Now, that said, all of this is available on GitHub, so you can go and test it out. So you don't need to worry about that. The data for it, that's also available there, so you can use it. The final feature importance for predictor is also available. As you can see, it's much more higher because we used a lot more data to train the same data set. Now, let's go back to the presentation. The summary of code is we loaded the data using tabular data set. We created the model using tabular predictor and .fit function through which we passed the input data. And finally, we predicted the values using the predict function and providing the test data. So it predicted the values for the test data. Given that I have given all of this, I have some helpful suggestions that you can use to get better at this with some next steps. The bonus slide that I was referring to. And that is this link here. Visit this link to download the demo code that we just discussed and test things out. If I have the car data and the car values data, but you could use other data sets. I pulled mine from Kaggle. You could also use Kaggle to pull in a different data set. There is also Hugging Face, which provides a lot of free data sets that you could practice on. Train your models by replacing train and test data set that I have in my set there. I also have a blog of this presentation here. That is the synonyms of my opinion, machine learning for newbies. Do check it out. It's the written form of whatever I've spoken so far. So if you prefer written, then yeah, this is where you can go to. Finally, these are some sources from where I've learned what I've learned and what I've shared today. I've learned a lot from AutoGluon GitHub repository. There is Kaggle, where I practiced many ML models before. Coursera was really helpful in clearing up some basic knowledge. And there is also Machine Learning University, which I attended, which was very helpful to make some of the concepts clear. Now, that said, the next is it's time for Q&A. I will stay online and respond to the chats. So let me know if you have any questions and I can clear them up. I'm going to stop sharing now. Himapriya, okay, so all is good. Okay, can you please show the CSV data? So can you please explain tabular predictor for predict small, the model creation? Okay. The CSV data, let's see, train.csv. This was the original, okay, not this, Carvana CSV. So this was the original CSV file. It had name, year, miles, and price. This is a humongous file with 22,000 lines. For testing, I just pulled out 1,000 of the last few lines, and the first 21,000 was used as train underscore data for training. But the smaller predictor model, we just gave the first 1,000 lines for training. And can you please, so the CSV is shown. Now, can you please explain tabular predictor for predict model, the model creation? Yes. So let's put it here. Tabular predictor. So this is where the model is created. Oh, and this is for the bigger model. Let's go to the smaller one, which you asked. So this is the function tabular predictor. Over here, the price is the column that we want to predict among all of these columns. So giving which column I want to predict. So telling AutoGluon to study column 1, 2, 3, and use that to understand how price came up. That's what we are saying here as price. Evaluation metric is just a way we are going to use for mean square error, and path is where a model would be stored. So predictor smaller has the model components, all the different models it has trained and all of it. The dot fit has the data small as well. Oh, I forgot to share my screen. Okay. So I'll do that. Sorry about that. So I'll probably explain this train predictor again. And the CSV was something that I showed earlier. So this is the name field, year, miles, and price. This is the humongous CSV that I was talking about. Forgot to share it earlier. Sorry about that. This has 22,000 lines. And the last 1,000 lines of this CSV was used for prediction. This file here, test actual, has those 1,000 lines, and it has the values here. So I removed the values for our test card data, which we use for which we provided our predictor to predict values for. And that was the first question. I hope that is answered. Now that told the predict smaller model, coming back here. So the price is the column that we want to predict. And the mean squared is the evaluation metrics that we were using it. This gives an idea of what it should use for the leaderboard later on. And path is where the model is stored. So predict smaller is a folder where it gets stored. Under models, you have all the different models here. If you don't give the path, data is going to be stored in this default location, AutoGluon models. While testing, I had done 2 of these, so it's just there. And for fit function, there is a lot of options that we could possibly have. One option is the preset option. So you could just add preset in here, preset equal to best quality, for instance. And if you run that, the model accuracy would increase, but it would also cost more time and GPU memory. So that's doing this would generate a model. It generates a list of different models, as you can see, predictor small. It generates all of these models, and when we do the click the predict function below here, it would, when we click the predict function and use the predict function, it automatically selects one of those models that it has built to do the prediction. And it selects which model to use based on how good and accurate that model is. And that's how leaderboard kind of gives us a view of that. I think the next question was leaderboard, so I'm going to continue on that. We have different models. So these are the score value tells how accurate that value is. Eval metric tells that they are using mean squared error, which we provided earlier over here. Mean squared error. So it's using this that particular Eval metrics to evaluate a model. Predict time val is telling how much time it's going to take to predict, and fit time is how much time it took to create the model and all of those fun values there. So that was it. This is what I wanted to avoid. Let's see. Stop screen share. I'll share it again if needed. Is test data labeled? Is the test data is labeled as we saw in the screen share? I can share my screen quickly again and show it. So the test data, car test, it has labels here: name, year, miles. It is labeled. We don't have the price column here because we want to predict that value. This was the actual price test file. I removed the price column so that I can let the models predict it. Is there any other questions? Courses in Coursera, I can't remember the one that I learned at the top of my head, but I'll put it on chat later on. The one that I learned was a 2 to 3 weeks course, and they really went in a lot of depth, talking about machine learning and everything, which was really nice. I also studied took some LLM courses in there. That was also very interesting, just to get a high level understanding of what happens in the various steps, like preparing data, training them, the models, and all of that. At the time that I went through it, used a lot of different libraries apart from AutoGluon. AutoGluon is something that I more recently learned at Machine Learning University at Amazon. Coursera, the ones that I went through used other techniques which were much more complex and difficult to grasp. Anything else? Okay. I'll end the stream for now, and I'll continue to answer any questions that comes up in the chat. Thanks a lot, everyone, and have an awesome rest of your day or night. Take care. Bye.